Hello friends, welcome back to Connect with Civil. This video deals with the analysis of concurrent force systems. Here is a question to find the resultant of the given system of concurrent forces. In the question, few concurrent forces are given and we have to find the resultant. So, what are concurrent forces? These are forces whose lines of action meet at same point. Next thing is, what is a resultant force? It is a single force that can produce the same effect which is produced by the given system of forces on a body. In the picture, three forces of different magnitudes are given. You can see the lines of action of these three forces meet at a single point. Moreover, for each force, the angle that the lines of action make with the horizontal axis is given. The first step is the resolution of forces. It is the process of splitting up the given force into a number of components without changing its effect on the body. As a usual practice, we resolve the force into two mutually perpendicular directions, that is, we get horizontal and vertical components. Since the given forces act in different directions, we can't simply add up all together to get a single resultant force. So first we are trying to resolve each force into its horizontal and vertical components. Let's see how to resolve the forces in different situations. Consider this figure. In this, the force F is inclined at an angle of theta with the horizontal axis. From this right angle triangle, we can get cos theta is equal to h by f and h is equal to f cos theta. Similarly, sin theta is equal to v by f and v will be equal to f sin theta. We can represent the force F, its horizontal component h and vertical component v like this. Suppose in another question the angle is given with respect to the vertical axis, that is phi. So horizontal component will be f sin phi and the vertical component will be f cos phi. Or otherwise, you can find the angle with respect to the horizontal axis as theta is equal to 90 minus phi and horizontal component will be f cos theta and vertical component will be f sin theta as in the first case. Now let's see the directions in different quadrants. We have seen the case of first quadrant, that is, horizontal component will be towards right and vertical component will be upwards. In the second quadrant, it will be vertical component will be upwards and horizontal component will be towards left. In the third, horizontal component will be towards left and vertical component will be downwards. Similarly, in the fourth quadrant, vertical component will be downwards and the horizontal component will be rightwards. Now let's consider our force system. The first force is 500 Newton inclined at an angle of 45 degree with the horizontal. The horizontal component will be 500 cos 45 and the vertical component will be 500 sin 45. Regarding the directions, horizontal component will be towards right and vertical component will be upwards. We can take these two directions as positive. The next force is 200 Newton inclined at an angle of 80 degree to the horizontal, but it is in the third quadrant. The magnitudes of the horizontal component will be 200 cos 80 and vertical component is 200 sin 80. Since the force is in third quadrant, the horizontal component will be towards left and the vertical component will be downwards. Since we have considered the directions in the first quadrant as positive, these both will be negative. That's why I have marked with different colors. The third one is 100 Newton inclined at an angle of 70 degree with the horizontal but in the fourth quadrant. The horizontal component is 100 cos 70 and vertical component is 100 sin 70. And the horizontal component is positive and the vertical component is negative in this case. Now we have finished the resolution of our given system of forces. Here you can see positive horizontal components are marked in red and negative horizontal forces is marked in pink. Blue line is the positive vertical force and green line refers to the negative vertical component. Now let's list out all our horizontal and vertical components together. These are the horizontal forces we got. In this, one is negative and other two are positive. On adding, we will get positive 353 Newton as the total horizontal force. Coming to the vertical components, we got one positive force and two negative forces. So on adding, our total vertical force is positive 62.62 Newton. Now we are with the total horizontal and vertical components. Here comes the resultant force. Refer this figure. In this, sigma h represent the total horizontal force and sigma v represent the total vertical component. The same thing can be represented like this also. So from this right angle triangle, we can get R is equal to root of sigma h square plus sigma v square and tan theta is equal to sigma v by sigma h, which means theta will be equal to tan inverse sigma v by sigma h. This is about the magnitude of the resultant. Now let's see how about the directions. In all the quadrants, the magnitude of the force and the angle can be calculated in the similar way. So this is how in the first quadrant the resultant looks like. Considering the second quadrant, this is how it will be. This is how it will be in the third quadrant and this is the fourth quadrant. Now let's calculate our resultant force. 353 is the total horizontal force we got, that is towards right, and the total vertical component we got is 62.62 upwards. So it is in first quadrant. So we can calculate the resultant as 358.53 and the theta as 10.06 degree. The resultant can be represented like this. Let me list out the steps once more. Observe the given system properly. Consider each force separately and resolve into individual vertical and horizontal components. While doing so, take due care on the direction of forces. Find out the total horizontal and vertical component. Directions to be taken care properly. The final step is to find out the magnitude and direction of the resultant force with the help of total horizontal and vertical force. Thank you.